There's the problem about the gas tank. And it says, suppose that the steel gas tank in your car is completely filled with, then the temperature is 17 degrees Celsius. How many gallons will spill out of the 20-gallon tank when the temperature rises to 35 degrees Celsius? The reason I took this really old car is because I figured that, well, here we could, maybe this is the gas tank. I actually don't know that, but at least it's on the outside, so let's assume it is, and we could actually see it. And then, of course, if it's still open, then the gas can spill out, and if it's not open, then with a rise in temperature, there could be some pressure exerted from the inside, and I don't know how big the stress and the strain is, but I'm sure it's not that great for the gas tank, and we kind of know that on a hot day we should not fill in the gas to the brim if we don't drive the car right away, because it will expand and could induce some stress, and that could be pretty bad to the gas tank and the car and the drivers, passengers. Okay, let's get started on this one here. So let's see what they're giving and what they're asking for. They tell us what the increase in temperature is. It's 18 degrees Celsius or 18 Celsius degrees. So it starts at 17 degrees Celsius, which is in the neighborhood of like 64 Fahrenheit, and then the temperature rises to about 100 Fahrenheit. 35 degrees Celsius times 2 plus 30 is 100. So over that temperature range from 64 to 100, which is 36 or Fahrenheit or 18 Celsius. I mean, kind of round it on the Fahrenheit part. Then they tell us that it has a volume of 20 gallons, so they tell us that the original volume is 20 gallons, and they tell us that this is a steel gas tank, so oops, not an alpha, but the beta, because that applies for volumetric expansion. And then we're supposed to come up with the delta V, because it says by how much does it flow out. So delta V. And then I just noticed that, you know what, the gas tank will expand. So beta delta T at beta steel. But of course the gas will expand as well, and that's of course what it's about. So I should make a double check mark here. We have both given the volumetric expansion coefficient for both the steel as well as the gas. Now when I look in the table on the coefficient of thermal expansion for volumes, I can see that that one for gasoline is quite a bit higher than that one for steel. So 950 10 to the negative 6 compared to 36 times 10 to the negative 6. It's almost 30 times higher. So that means actually that the expansion of the gas tank itself is rather negligible compared to the liquid, the gasoline itself. And we'll see that later when we subtract one from the other, that it won't have mattered as much. Okay, so here is for the gasoline, and it says delta V equals the beta for gas times the original volume of the gas. And I should make actually double check mark here as well for the volume, because the volume both for the gas as well as for the gas tank are given, and both of them are 20 gallons. And then times the delta T, which of course is given as 18 Celsius degrees. Now here one could think that we should convert to something more metric, but we actually don't have to. This one here is per Celsius degrees. This one here is Celsius degrees, so that units from these two divide each other, and then what we have left here is gallons, which means that the increase in volume is also expressed in gallons. So we can just leave it that way and come up with a result in gallons. And so I'm gonna try to push this a little bit over here. Oh, I can't. Never mind. Oh, I can push the car a little bit other way. There we go. And so equals, and then what I come up with is that 950 10 to the negative 6 times the original volume was 20 gallons times the increase and temperature is 18 Celsius degrees, so 0.342 gallons. That's by how much the gas expands. That's definitely not negligible. That's a third of a gallon. 3.42 as the temperature rises from the mid-60s on the Fahrenheit scale to 100. I'm going to write this as 3 significant figures. The problem actually suggests only 2, but you'll see here that in a moment when I do this here now for the gas tank itself, that I do need that extra figure. So the gas tank itself is going to be the same kind of equation. That's why I tried to copy that actually. Whoops, there's no delta. There we go, and then plug in the numbers, and that was 36 10 to the negative 6 times volume is 20 gallons again, and times 18 Celsius degrees, and I'm going to come up with 0.013 rounded, and then I subtract the 2. So minus, because now that the gas tank is this much larger, it can accommodate that much more gasoline, and so actually a little bit less than the number calculated here will spill out. So as I subtract the 2, I'm going to come up with 0.329, which is going to be a rounded 0.33, obeying the 2 significant figures. So 0.33 gallons is the correct answer, so pretty much exactly 1/3 of a gallon. Quite a bit.